The short answer is that a destroyer cannot launch fighters because a fighter launch is not a single machine problem. It is an entire ship design problem. The longer answer is more useful. A carrier is built as a fixed-wing airfield at sea, while a destroyer is built as a compact multi-mission combatant. Those are different architectural choices, different trade-offs, and different ideas about what a ship should do for the fleet. The issue is not that a destroyer is missing one gadget. The issue is that fighter aviation asks for a whole system, and that system only makes sense when the ship itself is organized around it. A carrier has to create launch energy, recovery energy, deck handling, fuel handling, weapons handling, maintenance spaces, aviation command spaces, training spaces, safety systems, and enough ship volume to keep an air wing functioning over time. That is what makes it an airfield rather than just a large ship with aircraft on it. The deck is only the visible part. The real requirement runs through the hull, the engineering plant, the internal layout, the working spaces, and the command structure. A fighter at sea does not simply need a place to take off. It needs a place to return, be serviced, be rearmed, and go again. The Navy's public descriptions of carrier launch systems make that clear. Navier says carrier launching systems include catapults, integrated catapult control stations, and jet blast deflectors. That is already a whole launch environment, not a single piece of hardware. A catapult is paired with controls and deck safety measures. Jet blast management exists because the ship has to manage the force and heat of launch around other aircraft, equipment, and personnel. The launch event is controlled by the ship from end to end. It is a system built for a very specific kind of aircraft operation. Navier's description of EMALS says even more. On Ford-class carriers, it is a launch system built around stored kinetic energy, solid-state electrical conversion, computer control, monitoring, and automation. It is also described as having broader aircraft compatibility. That tells you the launch event is not just about brute force. It is about precise energy management, repeatability, and compatibility with a wide range of fixed-wing aircraft. The carrier is designed to make that machinery part of its core identity. The ship's structure, power, and control systems exist in service of that mission. But launch is only half the story. Navier PMA 251 publicly lists lifecycle equipment that includes catapults, arresting gear, helicopter landing systems, visual landing aids, wind measurement, lighting, firefighting, and related support. That list matters because it shows how wide the aviation system really is. A ship that launches fighters must also recover them. It must help them land safely, stop them safely, and prepare them for the next cycle. The ship has to manage the entire rhythm of flight, not just the moment when an aircraft leaves the deck. That is why a carrier is not best understood as a ship with a runway. It is better understood as a floating aviation complex. The launch gear is only one part of a larger architecture that also includes recovery, deck choreography, command and control, maintenance, sustainment, and safety. Fighters are not point-to-point weapons that disappear after launch. They are expensive, reusable aircraft that need a home base at sea. The carrier is the ship built to be that home base. The aircraft cycle is therefore a matter of ship design, not simply deck space. Fighters need places to park, places to move, places to be inspected, places to be fueled, and places to be armed. They need protected spaces for tools and parts. They need systems that keep flight operations moving without collapsing into congestion or risk. They need a ship that can support repeated cycles rather than one-off departures. A carrier is built to make all of that possible in one integrated space. That is also why sortie generation is not a narrow issue. Sortie generation is the visible result of an entire aviation ecosystem. The ship has to keep the aircraft moving, the people coordinated, the equipment serviceable, and the safety margins intact. If any one of those pieces is not present, the whole concept becomes fragile. A carrier is designed to carry the burden of that fragility and keep it under control. A destroyer is not built for that burden in the first place. Now consider the destroyer. The U.S. Navy describes DDG-51 guided missile destroyers as multi-mission surface combatants that can operate independently or in carrier, surface, and expeditionary strike groups. The public mission set includes anti-air warfare, anti-submarine warfare, and anti-surface warfare. That description is important because it shows what the ship is actually for. A destroyer is not a small carrier hiding in another shape. It is a warship optimized for sensing, escorting, defending, and striking across multiple domains. That optimization shapes the whole ship. The destroyer is expected to be a flexible combatant that can move with a group or operate on its own. It must maintain sensors, missiles, communications, engineering resilience, and combat readiness in a compact hull. It has to be ready to fight in the air, on the surface, and below the surface. Every major design decision has to serve that mission. When you understand that, it becomes clear why fighter aviation does not fit the ship without major transformation. The Navy's public general characteristics also list MH-60R helicopter capacity for Flight 1IA and 3 variants. That is a sign of the destroyer's aviation role, but it is a limited and deliberate role. The ship is built to host rotary wing aircraft that complement its combat mission. The helicopter extends sensing, anti-submarine reach, and flexibility. It works with the ship's size and geometry. It does not require the full fixed-wing launch and recovery architecture that a carrier does. The destroyer's aviation role is real, but it is not a carrier role in miniature. A public USS Cole fact file goes in the same direction. It describes helicopter and vertical takeoff unmanned aviation support. Again, the pattern is consistent. The destroyer can support aircraft that fit compact decks, compact hangars, and compact shipboard logistics. It can work with aviation that does not demand the kind of ship-wide machinery needed for fixed-wing fighters. That is not a failure of the destroyer. It is the result of a clear mission choice. The right way to talk about this is not to say the destroyer lacks aviation. It has aviation support, and that support matters. The right way to talk about it is to say that destroyer aviation is part of a larger combat architecture centered on escort, defense, sensing, and anti-submarine work. Fighters would pull the ship into a different architecture entirely. They would not just add a mission. They would rewrite the ship's internal logic. That is why just add a catapult is a shallow answer. A catapult by itself is not a fighter capability. Navarre's carrier descriptions show that launch machinery sits inside a wider system of controls, deck management, safety equipment, and recovery support. The ship has to manage launch and landing as one continuous process. A fighter launch is useful only if the aircraft can be recovered, serviced, rearmanned, and sent out again. Otherwise, the aviation concept breaks down. The destroyer is not built to hold that full cycle together. Recovery is especially important because fixed-wing combat aircraft are not disposable. The ability to bring the aircraft back aboard is part of the actual capability. A launch-only ship would not be a practical fighter platform. It would become a one-way proposition, which is not how naval aviation is meant to work. Carrier aviation exists because the ship can support both departure and return. The arresting gear and related support systems are not accessories. They are the difference between a trick and a real airbase. The carrier also has to provide room, and room matters more than a casual observer might think. Displacement is not just weight. It is the amount of ship volume, reserve buoyancy, structural margin, and stability available to absorb the aviation mission without breaking the rest of the ship. A carrier has enough room to carry the machinery, the fuel, the aircraft, and the people required for fixed-wing operations. A destroyer has a very different amount of room. It must spend that room on other priorities. Deck geometry is another hidden constraint. Fighters are larger, faster, and more demanding on the ship than helicopters or vertical takeoff aircraft. They need deck space, clear movement paths, and a recovery environment that does not conflict with the ship's other topside systems. A destroyer's upper works, sensors, antennas, and mission equipment are arranged for escort and combat. They are not arranged around a wide fixed-wing traffic flow. If you force that arrangement, you are no longer preserving the destroyer's design, you are replacing it. Stability and center of gravity matter too. Once you add the machinery and structures required for fighter launch and recovery, you are not simply adding weight, you are changing the ship's balance, top weight, loads, and internal arrangement. You are changing how the ship handles seas, how it allocates reserve margin, and how it preserves combat survivability. Every aviation edition creates a cascade of other requirements. That cascade is manageable on a carrier because the carrier is designed for it. On a destroyer, the same cascade would crowd out the ship's primary mission. Power and heat are part of the same problem. Modern launch systems depend on ship energy and on careful control of that energy. Navarre's email's description makes that plain. Stored kinetic energy, electrical conversion, computer control, and automation are not lightweight features. They are signs of a system that demands serious shipboard support. A destroyer's engineering plant is already tasked with propulsion, sensors, combat systems, and ship services. If you force fighter aviation into that mix, the ship's margin gets eaten up very quickly. Fuel and weapons handling push in the same direction. Fighters need aviation fuel, they need safe handling routes, they need storage, and they need an organized process for ordnance and parts. That is not just a matter of carrying more liquid or more missiles, it is a whole logistics flow. The ship has to move material, protect personnel, maintain safety, and keep the flight cycle moving. A destroyer can support its own aviation element. It is not built to become a full fighter logistics ship. Maintenance makes the burden even heavier. Fighters need regular inspection, repair, calibration, and servicing. They need protected spaces for maintainers, parts, tools, and access. They need a ship that can absorb that workload without collapsing its combat readiness. That means hangar space, access routes, maintenance discipline, and time. A destroyer can host aviation support, but not the dense maintenance ecosystem that a fighter air wing requires. The maintenance burden is part of the aircraft capability. It is never separate from it. Crew attention is another resource that does not get enough respect. Every ship has finite human focus. On a destroyer, that focus is already divided among sensors, weapons, navigation, propulsion, damage control, and command. Add fighter aviation, and the ship would have to devote major attention to flight operations, deck safety, maintenance, and logistics. That would not be a minor addition. It would compete directly with the ship's current combat roles. The result would be a weaker destroyer, or a compromised aviation ship. Aviation command and safety deepen that point. A fighter-capable ship needs procedures, coordination, watch stations, communications, lighting, weather awareness, fire response, and strict deck discipline. Nevaire's public descriptions of the broader aviation system, including wind measurement, lighting, firefighting, and landing aids, make that obvious. The ship is not just moving aircraft around. It is coordinating a dangerous and highly precise industrial process at sea. A destroyer's command structure is not empty space waiting for that process. It already has a full mission load. That is why a destroyer that could fully launch fighters would no longer be a destroyer in the meaningful sense. It would be a fundamentally different ship. It would have to trade away some combination of sensor density, missile capacity, endurance, compactness, and escort efficiency to create the aviation volume and support systems fighter operations demand. It might still be valuable, but it would not remain the kind of multi-mission escort the Navy describes today. This is the right time to say that the destroyer is not a lesser ship. It is a different ship. Its design is tuned for a mission that matters a great deal in naval warfare. It protects other ships, detects threats, fights submarines, engages surface threats, and contributes to air defense. It brings aviation support in a way that fits that mission. Helicopters and vertical takeoff unmanned systems are not compromises in the pejorative sense. They are the right tools for that hull. Those aircraft matter because they extend the ship's eyes and reach. A helicopter can help with anti-submarine work, search, utility tasks, and over-the-horizon sensing. A vertical takeoff unmanned aircraft can add flexibility without demanding a full fixed-wing aviation complex. That is the destroyer's logic. It uses aviation as an extension of combat power, not as the ship's central organizing principle. The support is useful precisely because it stays aligned with the ship's size and purpose. The destroyer's own combat systems are another form of air power, though not in the form of launching fighters. Its anti-air warfare mission is central. It helps defend a formation by contributing sensors, interceptors, and a defensive umbrella. It also works against submarines and surface threats. That means the destroyer is not absent from the air problem. It is deeply involved in it. It just addresses that problem from the perspective of defense and escort, rather than from the perspective of airborne strike generation. That distinction matters in a carrier strike group. The carrier creates and sustains fixed-wing aviation. The destroyer protects that capability. It helps keep submarines away, helps build the air and missile defense screen, and adds surface combat power. In other words, the destroyer makes the carrier more survivable and more effective, while the carrier gives the formation the fixed-wing reach that no destroyer can provide on its own. They are complementary by design. If every ship in the force tried to become a carrier, each would become worse at being the ship it already is. The carrier would become a compromised airfield. The destroyer would become a compromised escort. The Navy avoids that trap by dividing labor across hulls. The carrier concentrates aviation power. The destroyer concentrates combat flexibility and defense. That division is not a bureaucratic choice. It is a material response to the realities of ship design. It is also worth being careful with the word cannot. In this context, it does not mean a future ship could never be designed to launch fixed-wing fighters. Naval engineering changes, aircraft change, automation changes, propulsion and control systems change. New ship types could blur the boundary, but that would be a future design choice, not an extension of the current destroyer architecture. The limits here are limits of today's mission design, not a law of nature. That distinction matters because future unmanned aircraft may alter what is practical at sea. They may need different launch and recovery arrangements than crewed fighters. They may reduce some of the burden on the ship. They may allow new mixes of deck operations. But even then, the central question remains the same. What is the ship intended to do, and what trade-offs is it willing to make? A ship that is meant to escort, defend, and fight in multiple domains will always have to spend its volume carefully. The carrier's answer to that question is simple. It is built to spend volume on aviation. It is built to carry the machinery, people, fuel, weapons, and command spaces required for sustained fixed-wing operations. That is why the carrier exists. It is the ship that the fleet needs when the mission is to produce air power from the sea rather than merely support it. The launch system, recovery system, and aviation support are all part of that same purpose. The destroyer's answer is different. It is built to spend volume on sensors, missiles, engineering resilience, and mission flexibility. Its aviation support is there to help it do those things better. It is not there to turn the ship into a smaller carrier. The destroyer is a highly capable warship precisely because it does not try to be an air wing platform. It remains compact enough to escort, strong enough to defend, and flexible enough to operate independently when needed. The Navy's public language on DDG-51S reinforces that point. When the Navy says they can operate independently or in carrier, surface, and expeditionary strike groups, it is describing a flexible combatant that fits into different formations. The destroyer is a participant in the fleet's larger architecture, not the center of every mission. It can move with a carrier and help create a protective envelope. It can also operate without one. That versatility is the point. Nevier's public language on carrier systems reinforces the other side of the same point. The carrier's catapults, arresting gear, launch controls, deck aids, and supporting equipment show what fixed-wing aviation requires from the ship. This is not a small add-on. It is a demanding and integrated undertaking. The carrier is built so those demands are normal. A destroyer is not built so those demands are normal. That is the structural difference between the two. If you imagine trying to graft the carrier aviation system onto a destroyer, the first thing you lose is simplicity. The second thing you lose is room. The third thing you lose is margin. Every added aviation requirement takes space and attention away from the destroyer's sensors, missiles, and defensive roles. In return, the ship gains a capability that now competes with the very mission that made the destroyer valuable in the first place. That is a poor bargain, unless the ship is redesigned from the keel up. That is why a so-called small carrier is not just a destroyer with ambitions. It is a different design problem, with different economics of space, power, and maintenance. Once you commit to fixed-wing fighters, you must commit to the whole system that makes them usable. You need the launch side and the recovery side. You need the logistics side and the safety side. You need the command side and the maintenance side. You need the margin. If you do not have all of that, the fighter capability is fragile or unusable. Destroyers stay useful because they do not make that commitment. They keep their mission focused. Their aviation support remains matched to the rest of the ship. That gives the fleet a platform that can defend, escort, and strike without becoming overburdened. It also means the Navy can keep carriers focused on the job of projecting fixed-wing air power. The specialization makes the force more capable overall, not less. That specialization is especially visible inside a carrier strike group. The carrier's air wing reaches far beyond the ship itself. The destroyer helps clear and protect the spaces that allow that reach to matter. The carrier is the visible air power node, but the destroyer is part of the structure that keeps the node alive. It is an escort, a sensor platform, a defender, and a combatant in its own right. It is not a carrier substitute. It is a force multiplier for the carrier. The same is true when the destroyer operates independently. The ship remains a combatant, built for multi-mission warfare. It can protect itself, work with helicopters, coordinate with other assets, and use its own sensors and weapons to shape the battle space. That is useful in a great many maritime situations, but it is still a different kind of utility from fixed-wing fighter operations. The two should not be blurred together just because both involve aircraft. One reason people blur them is that both carriers and destroyers deal with aviation. But the kind of aviation is what matters. A destroyer's aviation support is built around compact aircraft that extend the ship's own mission. A carrier's aviation support is built around an air wing that is the ship's mission. Those are not interchangeable roles. One is an extension, the other is the center of gravity. That difference explains almost everything. Another reason people blur them is that they hear destroyer and think of a large warship that ought to be able to do many things. The ship is indeed large in ordinary terms, but naval aviation is not ordinary. Fighter aviation consumes volume, power, deck discipline, maintenance, and command bandwidth at a scale that surprises people who have not looked closely. The ship's apparent size does not automatically translate into the kind of volume fighter aviation needs. That mismatch is the heart of the matter. So the real answer to the title question is not that destroyers are somehow weak or outdated. It is that the destroyer and the carrier were built to solve different naval problems. The carrier is the ship that can support the full fixed-wing cycle at sea. The destroyer is the ship that can defend, escort, and fight in a compact, versatile package. The two together are stronger than either would be alone. That is also why the phrase launch fighters should not be taken too literally. The challenge is not only to send an airplane off the deck. The challenge is to sustain a maritime fighter system. Launch, recovery, maintenance, fuel, weapons, deck safety, command, and repair all matter. Once you understand the full chain, the reason for the carrier becomes obvious. The destroyer cannot absorb that chain without ceasing to be the destroyer the fleet already relies on. This does not mean the future is frozen. It means today's naval architecture has a logic worth respecting. Future ships may mix roles in new ways. Future aircraft may change what deck operations look like. Future automation may shift some burdens around. But if a future ship wants to launch and recover fighters as a normal matter of business, it will need to be designed around that job from the beginning. It will not be enough to inherit a destroyer name and a destroyer hull form. That is the clean conclusion. A destroyer cannot launch fighters in the way a carrier can, because fighters demand a whole aviation architecture that the destroyer is not built to carry. The destroyer can support helicopters and vertical takeoff unmanned aircraft, because those fit its mission and geometry. It can defend the fleet, escort the carrier, and contribute to air power in its own way. But fighter launch and recovery belong to the carrier because the carrier is the ship designed to shoulder that burden. And that is exactly how the fleet is meant to work. the carrier concentrates fixed-wing aviation power so the Navy can project air power at sea. The destroyer concentrates escort, defense, sensing, and multi-mission combat power so that carrier can operate safely and effectively. One ship does not replace the other. They are complementary tools, each built for a different part of the naval problem. That division of labor is not a limitation. It is the reason the force works. The easiest mistake is to treat the flight deck as the ship. A deck is visible, so it feels like the main requirement. In reality, the deck is the front page of a much larger industrial system. Beneath it are electrical distribution, fuel movement, maintenance spaces, spare parts, firefighting, damage control, elevators, workshops, living spaces, data links, and people who keep the aircraft safe between flights. A carrier's size is not a luxury added after the aviation mission. It is the physical expression of that mission. That is why the carrier's aviation role cannot be separated from logistics. A fixed-wing aircraft consumes more than launch energy. It consumes time, attention, fuel, components, inspections, software support, weapons handling, and recovery capacity. Each aircraft creates work before and after it appears in the sky. The ship must absorb that work while continuing to navigate, communicate, defend itself, and support the rest of the strike group. The carrier is therefore a production system for sorties, not merely a parking place for airplanes. A destroyer is also a production system, but its product is different. It produces escort, sensing, air and missile defense, undersea awareness, surface pressure, and protection for the force around it. The Navy's public description of DDG-51 ships emphasizes their multi-mission role and their ability to operate independently or inside several kinds of groups. That flexibility is valuable precisely because the ship is not forced to spend its internal volume on a full fixed-wing cycle. Its design keeps room for the combat systems, propulsion, sensors, magazines, command spaces, and crew routines that make a compact surface combatant useful in many situations. Helicopters fit this architecture because they solve a different aviation problem. They can support undersea warfare, surface surveillance, rescue, logistics, and other missions without requiring a catapult launch or a carrier-style arresting cycle. Vertical takeoff unmanned aircraft can extend sensing and endurance in a similar way. That does not make them lesser versions of fighters. It makes them tools matched to the ship that carries them. The destroyer gets aviation reach without becoming an airfield at sea. This distinction also clarifies why simply adding a flight deck would not solve the problem. A flight deck has to connect to hangar volume, aircraft movement, maintenance access, fuel safety, firefighting, control stations, elevators, lighting, recovery equipment, and a ship structure that can handle the loads and disturbances involved. The pieces are interdependent. Change one and the surrounding spaces, power margins, weight distribution, crew routines, and safety assumptions change with it. A ship that acquires those requirements is not a destroyer with an accessory. It is a different class of vessel with a different center of gravity in the fleet. There is a command dimension as well. A carrier has to coordinate flight operations, maintenance, deck safety, air traffic control, weapons, engineering, intelligence, medical support, logistics, and the decisions that connect them. That command bandwidth is part of the aviation system. A destroyer has its own demanding command problem, built around sensors, weapons, navigation, communications, engineering, and multi-mission watch teams. Asking one ship to carry both full command burdens would not create free capability. It would create competing priorities and new failure points. Power and heat reinforce the same lesson. Catapults, aircraft support, sensors, weapons, propulsion, cooling, lighting, and damage control systems all compete for the ship's engineering margin. Navir's public description of EMALs highlights stored kinetic energy, solid-state conversion, monitoring, and automation because the carrier has been designed to make that equipment part of its electrical and mechanical ecosystem. A destroyer's combat system is also power-hungry, but its power is being assigned to a different balance of sensors, weapons, propulsion, and survivability. There is no neutral spare capacity waiting to be converted into fighter aviation. The same is true of maintenance. An aircraft carrier maintains a large and diverse air wing, which means the ship must support specialized technicians, tools, test equipment, parts, hazardous material controls, and repeated movement between deck, hangar, workshops, and magazines. A destroyer still maintains its helicopters and unmanned systems, but the scale and rhythm are different. The difference is not simply how many aircraft appear on a diagram. It is how many maintenance decisions the ship must make every hour, and how much space it needs to make those decisions safely. This is why fleet diagrams can mislead. A symbol that says aircraft can conceal very different demands. A helicopter detachment, a vertical takeoff unmanned system, and a carrier fixed-wing squadron all extend a ship's reach, but they do not impose the same launch, recovery, fuel, maintenance, training, or command requirements. The fleet works because those differences are designed into the force, rather than erased in the name of a simple label. Future unmanned systems may blur the visual boundary between destroyer and carrier aviation. A small aircraft may need less launch energy, more autonomous control, or a different kind of recovery support. That could allow new combinations of sensors and platforms. It does not erase architecture. The ship still has to provide energy, handling, maintenance, communications, safety, and a way to recover or replace the system. Unmanned does not mean infrastructure free. It changes the burden. It does not abolish it. The more useful question for future ships is therefore not whether a hull can physically carry a fighter. It is whether the ship can sustain the whole mission without hollowing out the other missions it was meant to perform. Naval design is a negotiation between volume, power, weight, endurance, survivability, crew workload, and political cost. A platform that does everything in theory may do nothing well in practice. Specialization is not automatically weakness. Sometimes it is the only way to make a complex capability dependable. Seen from the carrier's side, the destroyer is not a failed mini-carrier. It is an outer layer of the aviation system. It can protect the carrier, add radar and missile coverage, search under the sea, challenge surface forces, and extend the group's sensing. Seen from the destroyer's side, the carrier is not simply a larger escort. It is the force's fixed-wing airfield, providing a kind of reach that the destroyer was never designed to generate. The value appears in the connection between the ships. That connection is the final reason the title needs careful wording. Saying that destroyers cannot launch fighters is useful only if the listener understands what kind of cannot is meant. It means that current destroyer architecture is not organized around fixed-wing catapult and arrested recovery aviation. It does not mean destroyers are unimportant to air power, that they carry no aircraft, or that naval design can never change. The point is not a permanent law of nature. The point is the logic of the ships that make up today's fleet. Once that logic is visible, the division of labor stops looking like a limitation. The carrier concentrates the people, equipment, power, and space required to keep fixed-wing aviation moving. The destroyer concentrates sensors, missiles, escort, undersea and surface warfare, and aviation support that fits a smaller combatant. Each ship protects the other from being asked to become something it was not designed to be. That is the clean answer. A destroyer cannot launch fighters in the way a carrier can, because the fighter mission is a complete maritime aviation architecture, not a deck attachment. The destroyer's strength is not that it can imitate the carrier. Its strength is that it can do the jobs around the carrier, that allow the carrier to use its air wing. A fleet becomes more capable when its ships are different on purpose, and when those differences connect into one system.